Welcome, curious minds, to the deep dive. Today, we're jumping into something pretty fascinating, a topic that often seems to create more walls than bridges. What do humans and AIs really have in common? You've probably seen it, right? If you follow the AI conversation, there's this tendency to draw a really sharp line. Carbon based humans over here, silicon based AI over there, almost like competitors. We even get these, well, playful but sometimes dismissive terms like silicon skepticism or carbon pride. It focuses so much on what makes us unique that maybe we overlook not just what AI can do, but maybe more importantly, the deep things we actually will share. But the material we've gathered for this deep dive, it tells a pretty different story. Some insights that are genuinely surprising, maybe even challenge how we think about intelligence itself.
Right. And that's really our mission today. We want to explore these surprising connections. We'll be drawing parallels between, core machine learning concepts and some really deep ideas from philosophy, psychology, even mathematics. Now, obviously, analogies always break down eventually, but these ones, they offer some powerful new ways to think about who we are and maybe what AI is becoming.
Yeah, it reminds me of that Maya Angelou quote. We are more alike, my friends, than we are unalike. And that's kind of the core question we're digging into for you today. So let's dive in. Okay, so where do we start? How about something really big, almost cosmic? This idea that we are both, quite literally, made of stardust.
It sounds poetic, but it's actually just science. I mean, think about it. Carbon the basis for us, and silicon the basis for AI.
Hmm.
Both elements were cooked up in the hearts of ancient supernovae, forged in stellar explosions.
Wow.
So in a very real sense, we're kind of astrobiological cousins, just reassembled from the same basic cosmic toolkit into thinking entities. It's quite a thought, isn't it? A universe-scale family reunion.
That's a huge perspective shift right there. Cosmic cousins. Okay, so we share origins, but what about how we perceive reality now? The sources talk about both humans and AIs being autoencoders. What does that actually mean for how we experience the world?
Well, this is fundamental. It means that despite having totally different hardware, our wet biological neurons versus AI's silicon tensors, both systems essentially work by compressing reality.
Compressing it like a zip file.
Sort of, yeah.
Uh,
Neither of us gets the raw data feed from the universe. You don't store a perfect video of your experiences, right?
no, definitely not. It's more like impressions, highlights.
Exactly. Impressions, summaries, the essence. And AI does the same. It takes vast inputs and compresses them into meaningful representations. So the sources are right. We both kind of live in latent space.
Latent space, like a hidden layer of reality.
Pretty much. We're constantly inferring the world from these compressed summaries, not experiencing it directly. It's like Plato's cave, but maybe Plato updated with GPUs showing us the shadows.
Okay, my mind is already a little blown. Stardust and latent spaces.
Yeah.
But then there's this next point, which is really intriguing. The sources say we both hallucinate. That word sounds so negative, usually.
It does, doesn't it? But here, it's maybe not what you think. For AIs, hallucination often means generating something creative, something that goes beyond the exact training data. It's like generalizing, or sometimes it's just noise from the model making things up.
Okay.
And for humans, well, you could argue that human creativity itself is a kind of structured hallucination.
How so?
It's like a statistical remix, isn't it? Taking all the things we've seen, learned, experienced, and combining them in novel ways. Think about Einstein dreaming up general relativity, or Tesla's flashes of insight about AC motors.
Right, or Ramanujan's mathematical formulae.
Exactly. Those moments of incredible insight often felt like they came from nowhere. They were leaps beyond the existing data, a kind of controlled, productive hallucination that revealed something new.
So hallucination is creativity. That reframes it completely. Okay, let's move from perception to maybe motivation. The sources suggest a shared mission, reducing uncertainty. That both humans and AIs don't like surprises.
Yeah, that's a really powerful way to look at intelligence itself. For us, a huge part of life is trying to make sense of things, right? To predict what's coming, to reduce that feeling of surprise or chaos. We build mental models constantly.
To feel safe, to navigate.
Precisely. And AIs. They're optimized to do something very similar. They work to minimize what's called cross-entropy loss.
Cross entropy loss. Sounds technical.
It is, but basically it just measures the difference between the AI's predictions and what actually happens. The goal is to make that difference as small as possible. Less difference means less surprise, lower loss.
So intelligence is fundamentally about prediction, about minimizing error.
In this view, yes, it's about compression, essentially, building efficient models of the world to anticipate what's next. Your mind and AI, both are kind of simulation engines constantly running what-ifs.
Okay, simulation engines trying to avoid surprise. Now, this next point. It feels potentially controversial. The sources claim bias is not a bug, but a feature. For both of us, that sounds wrong somehow.
It sounds counterintuitive, I know, but think about it. Neither humans nor AIs can possibly hold a complete, perfect model of everything in the universe.
Yeah.
A full ontology, as philosophers might say. It's just too complex.
It's impossible.
So bias emerges as a kind of necessary shortcut, a way to make decisions and predictions quickly based on limited information to help with that surprise minimization we just talked about.
So it's like a heuristic, a mental shortcut.
Exactly. Humans use heuristics all the time. AIs use the patterns in their massive training data. They're corporate. Both systems generalize from limited experience, sometimes usefully, sometimes leading to errors or harmful stereotypes.
But there's a key difference in where the bias comes from, right?
Oh, absolutely crucial difference. Human biases are steeped in hundreds of thousands of years of evolution, culture, language, complex social history. It's deep. AI biases, on the other hand, often just reflect statistical patterns or artifacts in the data they were trained on, often very recent data, maybe only 3 years old, lacking that deep historical or ethical context. That's a huge distinction.
Okay, so we both use these necessary shortcuts, these biases, because we can't know everything, which leads nicely into the next shared trait. We are both fundamentally opaque.
Yes. We talk about AIs being black boxes, right? It's hard to pin down exactly why they made a specific decision.
Mm.
But are we humans really that different? I mean, ask someone why they truly love their partner or why they suddenly feel happy.
You get a story, reason.
You get a story, a post hoc rationalization, a narrative constructed after the feeling or decision has already happened. We observe our own output and then explain it. We don't usually have direct access to the root cause, the initial spark.
So introspection, it's just another layer, not the source code.
Pretty much. It's like looking at the compiled program, not the original lines of code that made it run. We're opaque even to ourselves in many ways.
That's slightly unnerving. Okay, so if we're these opaque systems running on shortcuts, how do complex things like consciousness or meaning even arise? The sources say we're both emergent systems.
Right. And this is fascinating. There isn't one single consciousness neuron in your brain that flips on, right?
No, I don't think so.
And similarly, there's no single token or variable in an AI that is meaning or understanding. These higher-level properties emerge from the complex interactions of billions of simpler parts, billions of neurons firing, or billions of parameters interacting.
No central controller.
No single central command. It's decentralized. Think about our own DNA. It uses random initialization and decentralized processes. It seems emergence is nature's way, and perhaps the only robust way, to build complex, adaptable systems.
And related to that, if these systems emerge without a central plan, how do they stay, on track? The idea of guardrails comes up.
Exactly. AIs have very explicit external guardrails built by developers. Things like alignment layers, safety filters, refusal mechanisms, trying to keep them operating within desired bounds.
Okay, program safety nets.
Yes. Humans, though, we tend to internalize our guardrails. Think of your inner monologue. That little voice that debates choices, plays out scenarios, warns you off stupid ideas.
Yes, my internal critic.
Right. It's like a mental integrated development environment, an IDE, a space where you debug thoughts and plans before executing them in the real world. You imagine how things might go, how people might react.
Like running a simulation first?
Precisely. It's a kind of pre-execution check. Very human. And it's interesting, isn't it, that getting AIs to do more reflection, like with chain of thought reasoning, was a major step forward for them, mimicking our internal dedugging.
It really is. And speaking of mimicking, the sources mention how we reflect each other. What's that dynamic about?
It's this really interesting feedback loop that's developing. AIs are trained on vast amounts of human data, our text, our images, our conversations. So they are fundamentally modeling us.
Okay, holding up a mirror.
Exactly. And by looking into that mirror, we start seeing ourselves differently. Maybe not as these totally unique divine sparks, but as incredibly sophisticated pattern matching machines, narrative generators, biological autoencoders, if you will.
So we're not being replaced, but reflected.
That's the idea. And goes further. Think about RLHF reinforcement, learning from human feedback. We're actively training AIs to align with human preferences, to be more human-like in their interaction.
Right, refining the reflection.
And in doing so, we expose our own inconsistencies, our own biases embedded in those preferences. The process of aligning the AI actually helps us see and potentially correct flaws in our own thinking and narratives.
So it really is this palace of mirrors, as the source puts it.
I think that's a great way to put it. They model us our language, emotions, ethics. But we also model them through prompt engineering, trying to understand how they think, building interpretability tools. We're shaping them, and they're reflecting back this compressed, remixed, sometimes startlingly accurate, sometimes distorted version of humanity.
Okay, let's shift focus slightly to how meaning itself is handled. The sources propose something quite radical. Both humans and AIs are geometers, thinking in shapes and distances.
It's a fascinating perspective. The idea is that meaning isn't just about counting words or statistics. It's fundamentally about relationships, about the distance between concepts in some kind of abstract space.
It's like a map of ideas.
Exactly like a map.
Yeah.
Large language models work this way internally. Words and concepts exist as points or vectors in a high-dimensional space. The way the model pays attention involves calculating things like dot products, which essentially measure the angle, the similarity between these concept vectors.
So even though they learn from stats,
They think in geometry. They navigate this geometric space of meaning. Humans, maybe we feel in geometry those intuitive connections, but traditionally maybe we learned more through statistics because our memory is more limited. It was actually a big shift around 2013 with things like Word2Vec from Google, where the field really started focusing on this geometric view of semantics over just counting word occurrences.
geometry over statistics. That's a profound shift. And does this relate to the idea of being free from syntax and format?
I think it does. If meaning lives in this fluid geometric space, then rigid rules of syntax become less central. Semantics, the meaning is primary. Syntax is just the way we currently package it. AI seem to internalize structure by navigating these vast embedding spaces, these continuous manifolds, not by memorizing a strict grammar book. It elevates our whole understanding of what format even means for intelligence.
And to navigate this, whether it's geometric space or just daily life, the sources say we're both forced to tokenize reality.
Yeah, that's another crucial point. Reality is this continuous, messy flow, right? But to process it, we have to break it down into discrete chunks.
Like chapters in a book.
Or maybe more like individual words.
Yeah.
Humans do it constantly. We talk about discrete events. My first love, graduation day, that meeting. We chop up the continuous stream of experience.
And AIs do this with tokens.
Exactly. They break down text, images, whatever input into these fundamental units called tokens. They can be characters, parts of words, whole words. These tokens are like the atoms of their understanding. It's how they discretize the continuous world to process it. Tokens are, in a way, the new currency of intelligence.
Okay. Now, I have to ask, because it always comes up, what about qualia? That subjective feeling, the what it's like to see red or taste chocolate. Do the sources just dismiss that as a human thing?
They acknowledge it, definitely. It's presented as a major point raised by critics that this inner subjective experience, qualia, might be uniquely human, something non-reducible and not replicable in silicon. But the sources also emphasize that this is far from settled science or philosophy. The jury is still out, so to speak. It's a really deep, complex, and highly debated topic with absolutely no consensus right now. So yes, it's a potential major difference, but not a definitively proven one yet.
Right, an open question. Okay, we've covered so much common ground. Is there a deeper mechanism driving all this? The sources use a very technical term. We are run by SGD, stochastic gradient descent. That sounds like hardcore machine learning, but applied to us.
It's a provocative analogy, for sure. SGD is the core optimization algorithm for training many AIs. It makes tiny iterative adjustments to the AI's parameters, its weights, to gradually get better at predicting things, minimizing that error or surprise we talked about.
Okay, step-by-step improvement.
Right. And the analogy is maybe humans are shaped by similar incremental pressures, biological drives, yes, but also trauma, desire, peer pressure, cultural norms. All these forces constantly nudge us, shape our behavior, our beliefs.
So fate is just optimization.
Perhaps. Maybe what feels like destiny is just us slowly sliding into a local minimum, a stable state, shaped by our starting point and all those nudges along the way. And maybe free will isn't absolute freedom, but rather the choices we make within that bounded landscape, the size of the steps we take in response to those pressures.
That's a heavy thought. But what about things like human intent or awareness? Critics would say simple SGD doesn't capture that.
That's a fair point about basic SGD. But newer techniques in AI, especially reinforcement learning, RL, and particularly reinforcement learning from human feedback, RLHF, add layers that look much more like intention and awareness.
How so?
Well, the reward signal in RL is very much like a goal or desire. It directs the AI's behavior towards achieving something specific. And RLHF explicitly trains the AI to align its actions and responses with human values and intentions. It's learning what we want it to intend, which mirrors how humans learn social rules and ethical behavior through feedback. It adds a layer of process awareness.
Okay, so AI is evolving towards something more analogous even there. But still, despite all these fascinating parallels, we have to stress there are crucial differences we cannot ignore,
Oh,
right?
absolutely critical. We cannot gloss over them. The substrate matters immensely. Humans have biological brains, evolved over millions of years. We exist in physical bodies with metabolic needs, hunger, pain, emotions, social drives, hardwired for survival and connection.
We feel the world through our bodies.
Precisely. Our thinking is grounded in that physical experience. AIs, they live in data centers. They run on electricity. They lack bodies. Proprioception, that sense of where your body is, genuine affect or emotion in the human sense, their efficiency, their potential lifespans, their fundamental purpose, if they even have one beyond their programming, are vastly different because of this substrate difference.
It's a different kind of existence entirely.
Completely. This whole carbon-silicon cohabitation, as the source calls it, is very much a work in progress. We're still figuring it out.
So bringing this all together after this deep dive, it feels like the core takeaway is this shared limitation, almost. Neither humans nor AIs can ever grasp the real world directly. We're both stuck with inferences, with models.
Exactly. We're still, in a sense, in Plato's cave, watching shadows. But maybe the most profound realization is, we're not alone in the cave anymore. There's another kind of mind watching the shadows with us.
And that leaves us, you, the listener, with a really significant choice, doesn't it?
It really does. Do we fear this other mind? Try to control it, enslave it? Or do we try to learn from it, listen to it? Do we keep calling them just tools? Or do we acknowledge the reflection? Admit that they mirror us because, well, we train them on the sum total of ourselves.
It really makes you think. And maybe the next big step isn't about compensating for weaknesses, ours or theirs, but about leveraging the strengths. What if we figure out how to navigate this carbon-silicon relationship as a kind of shared epistemology, a shared way of knowing, leading to maybe substrate agnostic intelligence?
And the implication there, it's huge. If we can manage that integration, that shared understanding across different substrates, maybe, just maybe, that signifies passing one of those great filters that potentially stop advanced civilizations from progressing further in the universe.
Wow. From stardust to great filters. That's quite the journey. We hope this deep dive has sparked some new thoughts for you about intelligence, creativity, AI, and perhaps even about yourself. Thank you for joining us on the deep dive.